The features and principles of operation of the Shaft Sheriff communication system is covered in this video. Firstly, let's take a look at the Guduza corporate profile. Guduza System Technologies, the OEM of the Shaft Sheriff, has been servicing the mining industry for over 36 years. During this time, they've been doing business with all of the major mining groups in South Africa. Guduza also has systems in many countries around the world, the oldest clients being in Australia, Canada and the Philippines, with over 15 years of operation. The range of products designed mainly for underground deployment is illustrated in the product wheel and spans the product categories: environmental monitoring, conveyor belt control, rescue communications, as well as shaft, voice and digital communications. The Shaft Sheriff and its predecessors have been in operation for over 23 years and have been subject to some of the harshest conditions in the world, working under extreme temperatures from the Mongolian desert to the icy polar regions of Russia. The Shaft Sheriff, coded the CCS3000, is a shaft communication system with tight and slack rope monitoring functionality. The Shaft Sheriff has additional features, namely voice and data communications, as well as signaling capabilities. In South Africa, where conveyances are moving at high speeds of 31 miles per hour or 50 kilometers per hour, are traveling down to depths of 1.9 miles or 3 kilometers deep into the earth. These mines, being the deepest mines in the world, have systems in place to safeguard people and property. Guduza's high-tech electronic and rugged mechanical design has proved itself over and over again in terms of safety and reliability. The primary features of the Shaft Sheriff is to monitor the conveyance while moving through the shaft for the event where an obstruction is encountered, thus causing an unsafe condition. The Sheriff, which is constantly in surveillance mode, is monitoring the mass of the conveyance for any variances. If the variances exceed the higher or lower set limits, it will send a message to the winder stopping the conveyance before damage can be done. The Sheriff takes into consideration the varying conveyance payloads and changes the critical trip point parameters accordingly. To be viewed later under the HMI section. The Shaft Sheriff also provides loud and clear voice communications from the underground conveyance to the surface and back again, as this is a full duplex system, meaning that voice and data moving up and down the shaft is happening simultaneously. The facility exists for the driver to listen in to voice communications in the conveyance. The audio unit installed onto the conveyance room wall will communicate with the audio unit on surface, the ECU. Additionally, a walk-on unit can be provided, which is portable and can be used outside of the conveyance, giving the inspector communications with the surface winder driver. Bidirectional signaling from the conveyance and surface is performed through selecting the belling button on the audio unit or using a keypad to generate the correct belling signals. Thus ensures the correct bells are sent to the driver. No human interpretation needed. Knockers, a method of belling used in the mining industry, can also be accommodated by the Sheriff. For more modern mines, it is recommended that the Shaft Sheriff automatic conveyance system is used that operates like a high-rise building elevator. As an option, a bell recorder interface relay can be provided, which follows the bell signals from the cage and surface, providing a relay contact output for the mine's bell recorder. Alternatively, a PLC-based bell recorder can be provided, This logs all of the belling signals and is provided in a tamper-proof format. The shaft sheriff provides digital communications both up and down the shaft. This has been designed in a modular way for ease of upgrading, in steps of 8 digitals per printed circuit board, up to a maximum of 56. This allows the monitoring of conveyance doors, booms, poles, brakes, and all things that need to be monitored for production and safety purposes. These digitals provide the hoist PLC with criteria to interlock to the driver's function, thus preventing the conveyance from moving away accidentally. 2 analog channels per printed circuit board is available. One of the 2 analogs is allocated to the monitoring of the battery on the cage. The other analog channel is client selectable. By adding additional I/O cards, the load per rope in a multi-rope system can be monitored. Both analog and digital screens to be viewed later under the HMI section. Wireless communications in a mine shaft, where the shaft behaves like a waveguide for radio frequencies, has its set of challenges, namely scatter and standing wave ratios, SWR, this causing possible dead spots. For safety systems, maximum reliability must be ensured. The 3 typical methods of communication currently being used are point-to-point radio frequency communications from the surface to the moving cage, cables running down the length of the shaft with electronic boosters for communication with the moving cage, and thirdly, using the winder steel rope as the radio frequency communication medium connecting the cage to the winder. The shaft sheriff using the steel rope as its communication medium does not have dead spots and has proven its ability to communicate down long vertical shafts with maximum reliability. The shaft sheriff, being a safety system, has been designed to fail safe. Should its electronics become defective, i.e. the communication between cage and surface fails, the winder will trip. The system has been designed in a modular way for the ease of installation, maintenance and fault finding. This approach also minimizes the spares holding. The built-in test equipment BITE has LEDs placed at strategic points in the system that will assist with the quick localization of faults. In summary, downtime is drastically reduced due to the rapid diagnosis and easily replacement of defective. The PLC-based HMI human-machine interface gives a visual indication of the system status parameters and comes with a screen of suitable size for the driver's cabin. A Modbus output can be supplied to the mine in order for them to project this information onto the existing control room monitor. There are 2 categories being offered, namely state of health of the system, productivity and management tools. The explanation of health monitoring is as follows. On the home page, the critical parameters are displayed. This shows the conveyance mass measured in tons. The RF communications lamp, which is green, indicating that the carrier signal is present. When the carrier signal is lost, the lamp turns red and the winder will trip. The reset request lamp will also turn from green to red, this being the system's fail-safe mechanism. In order to reset the system, a request must be sent to the sheriff. The cage battery lamp remains in the green state while the battery is healthy. When the battery voltage drops below 11 volts, the lamp turns orange, indicating battery low. If the battery voltage drops below 10 volts, the lamp will turn red and the system will trip. From the home page, we navigate to the main menu, where one of the following pages can be selected: doors, poles, clamps, trip settings, alarm log, and I/O. We now drill down to the doors display. This displays the status of the doors, opened or closed, for all decks. An open door is represented by a flashing lamp. Poles display. This displays the status of the poles in or out of position. A pole out of position is also represented by a flashing lamp. Clamps display. The clamps display page indicates when the clamps/brakes are engaged or disengaged. Clamps engaged is indicated by a non-solid block, as can be seen on the screen. Trip settings display. The slack and tight rope warning and trip settings have been set up as follows. Tight rope parameters. Tight rope warning 25 tons. Tight rope trip 27 tons. Slack rope parameters. Slack rope warning 5 tons. Slack rope trip 3 tons. These values are calculated by the mine engineer. The mass follower has been set up for 10% for both tight and slack rope conditions, to be explained in more detail in the next section. As can be seen, the cage mass expressed in tons is increasing. Once it reaches 25 tons, that is the tightrope warning point, the warning lamp changes from green to red. If the mass continues to increase to the 27-ton trip mark, the red lamp will illuminate and the winder will trip. The mass is now decreasing, as can be seen on the screen. If it decreases to 5 tons, the red slack warning lamp is illuminated. If it persists and drops to 3 tons, the red slack trip lamp will illuminate and the winder will trip. The alarms, as well as other events, i.e. doors, poles out of position, are recorded in the HMI. On request, an encrypted file can be saved to a USB flash drive. The mass follower. The main purpose of the mass follower is to make the shaft sheriff more sensitive, increasing the response time to a tight or slack rope condition. This is done by taking a snapshot of the actual total mass of the conveyance, including payload, just after the brakes are released. The mass follower percentage, as indicated on the screen, is added to and subtracted from the actual total mass of the conveyance, thus creating more optimal trip points. The mentioned configuration setup, being for a specific client, can be altered to meet almost any client requirements. I/O display. This page gives an overview of all of the digital inputs and outputs, as well as the analog outputs, as can be seen on the screen. The digitals are being switched on and off. This page is generally used for quick reference by maintenance staff. Productivity tools. This will, however, require, in addition, the installation of proximity switches positioned at plan points in the shaft. Productivity tools are tons per trip, time taken per trip, trips per shift, time per stop point, and total tons per shift. The event logging facilities allows ongoing shaft system related activities to be recorded, which includes the events occurring prior to an incident. The value of this feature for safety authorities should be considered. Other products in the Shaft Sheriff Communication Suite. The Shaft Sheriff, which covers the full spectrum of functions, also has a number of subsets, namely the CCS3000, the CCS4000, and the CCS4080 Shaft Sheriff Mini. The SMS, which is a basic system offering Titan slack rope functionality as well as 4 digitals. The SIS, on the other hand, provides audio communication and has a belling function. And finally, the CCS4080, the Shaft Sheriff Mini, which provides audio, belling, and has 8 digitals. The final product in the product suite is as follows: the automatic conveyance system. The Shaft Sheriff automatic conveyance system allows the cage to be operated in a high-rise building elevator mode, meaning that by selecting a push button that represents a specific level, the conveyance will automatically move and stop at that level. No traditional signaling is needed. Apart from speeding up the dispatch process, it also eradicates possible manual signaling errors. The system operation. The functionality of the Shaft Sheriff, already explained in a static way, will be brought to life in the next section, giving a full dynamic view of its operation. To set the scene, we show a typical conveyance in a shaft with the rope connecting the winder to the conveyance. The Shaft Sheriff has a number of units on and in the conveyance. A deep charge battery enclosed in a metal housing is placed on top of the conveyance, and the audio unit is attached to the inside wall of the conveyance. In order to explain the remaining units, we now zoom in to the conveyance and see the load cell located at the top of the conveyance and is attached to the drawbar. The output from this load cell, representing the mass of the cage in millivolts, is sent to the Shaft Sheriff conveyance unit. The signal is processed, radio frequency modulated, and sent through to the cage omnicoupler. This signal is then tapped off at the surface omnicoupler and sent to the Shaft Sheriff surface unit. The main processing is done within this unit. Tight slack, lock bell, and carrier fail information is sent through to the mine's hoist PLC, and the hoist PLC will then make the decision when to trip the winder. Attached to the Sheriff surface unit is a display, and this shows the continuous mass of the conveyance, readings presented in tons. This display also shows the system error messages. The audio unit ECU, which is connected to the Sheriff's surface unit, is positioned on the driver's console. This provides the driver with voice communications to the person in the conveyance. In conclusion, the Shaft Sheriff over the last 23 years has provided the required safety and communication capability in the shaft environment, and has lived up to this reputation in South Africa and all round the world.